Hey, good evening, everyone. Thanks everyone for joining, especially the ones from Europe, as it's almost midnight over here. The good thing is that no one can judge me now for having a glass of wine during our session. My name is Lukas. I'm product manager at Gnosis, and I'm joined today by Richard, who's the tech lead of the Gnosis Safe. And we would like to give you an introduction to what Gnosis Safe is, and how you can build on top of it to leverage smart contract account features. So here's roughly what the next hour is going to be structured. For the first 20 minutes or so, I will give you a rough overview of the Gnosis Safe and how we'd like to see its role in the ecosystem. I start by explaining why we want Gnosis Safe to become the new account standard for managing digital assets. Then I will show you how we want to make it as easy as possible to interact with DeFi using Gnosis Safe. Then I will go into how we build Gnosis Safe as an open system. And finally, I will show you how Gnosis Safe can be used as a portable account that is not just tied to one product, but can actually become sort of a universal login. So if you don't like product presentations, please bear with me. I will try to spice it up a little bit with a couple of live demos in between, and I'm just hoping that not all of them will fail miserably. In the second part of this session, then Richard will take over and we'll do some live coding where he will build a little Dapp that leverages the benefits of the Gnosis Safe. So let's get right into it. Why are we building Gnosis Safe? In the Gnosis Safe team, we see the power of blockchain in enabling true digital ownership. This is something which was not possible before because ownership of assets in a digital context has so far always required intermediaries. This is not ideal because intermediaries have clear incentives to make it as hard as possible for users to leave their platforms. And they want to build closed-off systems with limited ways for third parties to integrate and innovate on top. So with blockchain technology and digital assets, we have an opportunity to give back ownership to users and to build an open system that actually fosters innovation. These digital assets, of course, include currencies such as stablecoins, as well as stocks, options, and other investment products. But not just that. Blockchain also enables digital ownership over private data, for example, by having encrypted data stored using Filecoin. And we also see increasingly ownership rights as digital assets, such as governance tokens and security tokens. And then there is, of course, a long tail of other types of digital assets, such as art, identities, certificates, and a bunch more. So we've built Gnosis Safe as a trusted way to manage all of these digital assets and to enable true digital ownership over them. Gnosis Safe at its core is a smart contract-based account. So compared to regular externally owned accounts, Gnosis Safe has its logic defined in a smart contract instead of at the protocol level. This makes Gnosis Safe accounts much more powerful and flexible than externally owned accounts. So our focus is to make Gnosis Safe the new account standard, because we think the way accounts work today on Ethereum and other EVM-based chains has some significant drawbacks. We need to overcome these in order to enable widespread adoption of digital assets without having users fall back to centralized services such as exchanges or custodians because of convenience reasons. So let's highlight some of the concrete benefits of Gnosis Safe as an account. First, Gnosis Safe enables advanced access control mechanisms. Externally owned accounts have a very binary access logic. Whoever has access to the private key basically controls all the assets associated with it. But with a Gnosis Safe account, the access logic can be defined freely. This enables, for example, accounts being controlled by multiple private keys, having threshold signatures, or even more complex things such as spending limits, whitelisting, or recovery mechanisms. Second, Gnosis Safe allows to batch multiple smart contract interactions together into one blockchain transaction. So when an externally owned account would usually require users to sign multiple transactions, for example, when doing an improve and transfer, Gnosis Safe can batch those into one transaction. By doing that, we can achieve vastly better user experience when interacting with the blockchain. And finally, Gnosis Safe allows for transaction relaying using meta transactions, which allows users to pay transaction fees in other assets than the native currency of the blockchain, or even have transaction fees abstracted away completely. So users don't have to deal with them at all, and they don't have to experience the issues when, for example, transactions are getting stuck because the gas fee is set too low. We at Gnosis have built our own interface on top of Gnosis Safe to leverage those smart contract capabilities, such as batch transactions and advanced access control. This interface is called Gnosis Safe Multisig, and it focuses on having digital assets be controlled by multiple private keys. While most of our users are companies today that use the Gnosis Safe Multisig for joint fund management, it is also increasingly being used by individuals that want to have a more trusted security setup. So let's jump into the first live demo, where I will show how the Gnosis Safe Multisig interface looks like. Let me just check how to change the sharing options. So I hope you all can see the app now. I will go ahead and create a new save. I will have to give it a name. The name is just stored locally in the local storage of the browser. So I can give it a secret name. You can see at top that we're connected with the Portis wallet, which is my choice for this demo, how to store the private key. But we support a wide range of different wallets, including hardware wallets, mobile wallets, etc. So this Gnosis Safe account is now controlled by this Portis key. I could add more owner keys here, but for now, let's just leave it like that. The transaction is signed, and what we're doing now here is deploying a smart contract, actually a proxy contract, and it's already done. So we've created a Gnosis Safe account here, and we're here ending up on the assets list of my Gnosis Safe. So what I would do now is to send some assets to the safe. This might take a while. Just going to scan this QR code with my mobile wallet. Going to send some Ether. Okay. And while we're waiting for the Ether to arrive, I will go into settings. And there you can see that I could change the name of my safe here, but I can also see the owner keys, which currently is just one key controlling the safe. And I would now go ahead and add a second key to make it a real multi-signature wallet. So let's say Alice wants to join as a signer of this safe account. Use ENS names here. Now I can set how many signatures are needed to make anything with this account, like sending out assets. Let's say both of us have to sign. There we go. So we also see here now that we've got some incoming Ether. And yeah, that's it for our first demo. Let's go back to the slides. So some stats about the Gnosis Safe. Both the contract and the interface that you've just seen are available on 3 mainnets today. That includes, of course, Ethereum mainnet, but also XDAI and the Energy Web Chain. And in total, over 50,000 accounts have been created so far, making more than 350,000 transactions and storing over $1 billion worth of digital assets. We think that we've now achieved the tipping point where smart contract accounts really start to take off and become widely used in the ecosystem. Just an example here in this chart, you see how the number of new accounts has increased quite significantly in just the last months. But Gnosis Safe is not just an account that enables users to store digital assets, because users also want to participate in decentralized finance, partake in governance activities, and do other things with their digital assets. One way we enable users to do this is through Safeapps. Safeapps are third-party apps that can be just like normal web apps that are hosted on a website or IPFS. And those apps are then loaded in the context of the Gnosis Safe multisig interface via an iframe. So developers have full control over the user experience in this app. But once the app actually triggers a transaction, the Gnosis Safe multisig takes over and shows the user exactly the details of this transaction. So this means that the user still only has to trust the Gnosis Safe multisig, because we show exactly what the Safe app wants to do with their assets. The Safe app communicates with the Gnosis Safe multisig via the Safeapps SDK, and Richard will later show you how it works exactly and how we can build Safe apps using this SDK. So our users really like to have this one trusted interface, especially the ones dealing with a lot of funds, because they basically try to minimize the number of counterparties they have to trust as much as possible. And for developers, on the other hand, this means direct access to this existing user base and having this security double check-in built right into the system. But also developers can take advantage of transaction batching to deliver a smooth user experience for a user. So let's go back into the demo and I'll show you how Safeapps work from a user perspective. All right, so we have this apps tab down here. Because we're on Rinkeby, there's just a couple ones that are compatible with Rinkeby. On the Ethereum mainnet, we've got a bunch more. But let's just try Sablier here. So Sablier allows to stream money by the second. And let's just choose Ether and then open the stream to, let's say, my Portis account. And I'm going to send 0.1 Ether. So the stream will start tomorrow, midnight, and is going to last about a week. So we're now all set. Now when I create a transaction, you can see that now basically this is displayed by the Gnosis Safe multisig app, not the Safe app. And I can see already that there's 3 transactions involved that are here batched together. So I can submit the creation of the stream. Transaction is signed. Yeah, there's a bunch of, yeah. And if I go back to the transaction list, you can see that we've created this transaction. And because I've now set the threshold for making transactions to 2 out of 2, meaning that Alice still has to sign this transaction before it actually goes out. What we see here on the left is basically that we've got this transaction batching going on. So we've got 3 transactions that are made as part of this Safeapp interaction. I'm sending some Ether to the wrapped Ether contract, doing an approve where I approve for the Savior contract to use this wrapped Ether, and then contract interaction with the Savior smart contract to create the stream. So, as mentioned before, we are not really fans of closed systems at Gnosis, and we know that if we really want to make Gnosis Safe this new account standard, we need to have it as a truly open system. What do we mean by that? We have the entire Gnosis Safe infrastructure, from the contracts, the transaction indexer, relay service, the SDKs, and even our interfaces. All of them are fully open source. So we're always happy, of course, to see developers forking our projects, modifying them, improving them, contributing to the code base. But yeah, so everything we do is open source, and we also pay special attention to make Gnosis Safe as modular as possible. So the Gnosis Safe account can be extended with custom smart contract modules to add additional functionality on a smart contract level, whereas the user is always in control what modules are active with their accounts and can remove those modules at any time. Gnosis Safe is also extensible on an interface level, where users can freely add any Safe app. So we are intentionally not making this kind of like App Store, not a closed system, because we don't want to end up being a gatekeeper and having this closed system. So just to show you how this extensibility works, let's do the last demo for today. Let's go over to the Gnosis Safe multisig. Now, when I go to apps, of course, there's the one that are already loaded, where we already have some default ones, but the user can always add a custom app here. So I've just got one here that's currently in the Safe app that's in development, where you can create custom market maker strategies for the Gnosis protocol. And just like that, I've added a new Safe app, and it's now available in my Gnosis Safe multisig. So the user really has a free choice of like adding new Safe apps and not having to ask Gnosis for permission, or us basically being the gatekeeper here. Yeah, besides that, in the settings, you could also see that here there's a Safe modules section, where if I would have some smart contract modules attached to my Gnosis Safe account, they would appear here, and I could remove them at any point. Yeah, we want Gnosis Safe to become a portable account, which is not tied to one specific interface, but that is actually compatible with a wide range of wallets and dApps. So to show you an example of how this works, I will just play a quick video of how a user can access their Gnosis Safe account from the Tonk wallet, which was recently released by Rockside. Rockside has built this wallet to showcase their own Gnosis Safe relayer infrastructure, which guarantees that the user's transactions are executed quickly without having to overpay. So let me check if the video works. So here, just a QR code being displayed in the Gnosis Safe multisig interface, and in the Tonk wallet, mobile wallet, just scans the address of the Gnosis Safe account, and it's adding the seed phrase of the signer key, so the user can later also do some transactions with it. And just like that, in about 20 seconds, the user has ported their Gnosis Safe over to the Tonk wallet. And there's actually an increasing number of other interfaces that support Gnosis Safe accounts and leverage its capabilities, such as Dapp and Circle's UBI, for example. Yeah, we also offer SDK for Dapp developers that want to build standalone dApps, yet still give their users Gnosis Safe accounts. So in this case, even though users interact with the Dapp just as usual with their MetaMask or Ledger wallets, under the hood, the Dapp actually assigns a safe account to the user and can therefore leverage all the benefits of the safe, such as batching transactions and abstracting away transaction fees. All right, just to summarize, we built Gnosis Safe really to empower users. We want users to take back control over their own assets and have this as easily and securely as possible, because this way we prevent users opting for centralized services for like convenience reasons, for example. So we don't end up doing basically the same mistake and building a system run by intermediaries, where again, those intermediaries would only be interested in building strong platform lock-ins and extracting as much value as possible from their users. And on the other hand, we don't just see Gnosis Safe just as a product. Rather, we want to make Gnosis Safe an ecosystem where the community can contribute, can integrate, extend the Gnosis Safe account permissionlessly. And we're continuously working on removing barriers for developers to build on top of Gnosis Safe, because we know that the resulting innovation we achieve by that will eventually also benefit our users. And with that, I want to hand it over to Richard, who will be doing some live coding and showing you how you can build on top of the Gnosis Safe.
Thank you, Lukas, for the nice presentation and introduction to the Safe. Let's see how the live coding will go, because you know, live coding is live. Probably doesn't work. I want to share my screen. So today I want to show how to use the Safe and how to write Safeapps, or like a simple version of it. The example that I will present is based on a tutorial written by one of our developers, or multiple of our developers. And it's the target of the Safeapps that we want to write is a very simple use case. We just want that we can upload a file that contains a list of addresses, and then we can send money to all of these people. So similar like airdrop, or you can just customize this and then you can use it to actually like send out payments to your employees. And yeah, we want to see how simple this is to write such a Safe app and all this distribution of these funds will all happen in one transaction. So it's not necessary that you then, if you have 20 or 100 employees, that you do 100 transactions. So we achieve this by using the Contract Proxy Kit. The Contract Proxy Kit is an SDK that allows us to use the Safe in standalone apps. It also allows us with some very small adjustments to automatically use then these standalone dApps inside the Safe web interface as a Safe app, as Lukas has shown us before. I already set up a very simple empty project. It should be this one. So this is basically a normal React project, and we have a simple entry page where we right now only have a connect button, and as soon as we are connected, we show the address of the connected wallet. So this has nothing to do with the Safe yet. This is a pure simple dApp. So we can see this here. So if we press connect right now, connect to our MetaMask, this is my testing Rinkeby MetaMask account, and this will be then shown. So in the first step, I would like to adjust this to use the CPK. I'm going to cheat a little bit, so I'm going to have the solution on one side, and like you know, instead of using Stack Overflow to copy paste, I'm going to use the finished app to copy paste. So let's start with adding the CPK. So the normal CPK for the standalone version, we still need the provider. So what normally happens is that after you connect it to your MetaMask, we use this MetaMask account to create a Gnosis safe specifically for you, or like, but the safe doesn't need to be created in the beginning. So we assign a Gnosis safe to you. This can be used, and it will be deployed as soon as you make your first transaction. It's not really required that the safe is deployed before. So whenever you use your account again, wherever the CPK is used, you can reuse your proxy, and you don't create additional like gas cost by creating new proxy. So for this, it's required that we can have an account, so to which we can assign this proxy, right? So for so the first step is that we have this hook here. This is from the Web3 Connect library, where we get our provider. And currently what we do is we use this provider, fetch the account, and set this in our account state. So what we do first is we import CPK and adapter, which is required depending on our library. So I'm developing right now using ethers. Therefore, I need the ethers adapter. We also have support for Web3, for Web3 2.0, also for like the different ethers versions. So for ethers 4 and 5 currently. And it's easy to extend that to your favorite Web3 library. And the CPK is a base SDK. So what we do now is we take our provider, and we want to create a CPK instance. So the CPK instance, what is important here, it takes this ETH-lib adapter. So this is one that we need to build. To build this ETH-lib adapter, we need to pass in the ethers instance. So that's something we will add here. And we need to pass an assigner, and assigner can be requested from our provider just by calling get signer. Now that we have the CPK, let's add a state variable to store this in. So we're gonna go with Proxy Kit, and then we're gonna call Proxy Kit with the CPK. And now, actually, we don't really want that to see like the owner account. What is way more interesting for us is to actually see, so what is the address of the proxy this is assigned to us, right? So, and the important part here is actually that even before this proxy is created, we already know the address because we use a deterministic deployment facilitating create2. And by doing this, we already know on what address the proxy for you will be created, or for your UA, even before this account is created or deployed. So this way, we can already start building transactions that are based on your address. You can start funding the account, you can interact with it without having to deploy it, and we can batch the deployment together with the first transactions that are being made from this account. So saving a lot of gas, and also the user doesn't have to sign like multiple transactions to deploy their account. Now, we should update this a little bit because now we use some states here. We don't want this quick. We can say in our, if we have the proxy kit and if we have a wallet state account, then we show this. So let's see how this looks when we update this now. So I have the app running in the bottom. You see it should compile rather fast. Then we want to go to this one. Now that we connect, we actually don't see the MetaMask account. So the MetaMask account would be the one starting with 05C8, but we see the proxy address that has been created for this MetaMask account that we can start interacting with. So this also means if I now switch my MetaMask account to one of my other accounts and refresh the page, I probably have to reconnect, yes. We'll see that I get a different proxy because the proxy is very specific to the connected MetaMask account, and every MetaMask account gets their own proxy. In some cases, if it's required that actually each Dapp creates their own MetaMask account, it's possible that that the Dapp can specify an identifier for their own Dapp, and this will then be included into the create2 process to create a very specific account for this Dapp. Okay, let's continue. Now let's write the real logic. So what we want to do is basically we want to have in this view, we want to have a field where we can select a file and upload this file. So, you know, as I said, I prepared this code. So because I don't want to show how to write React code. It's also not my strongest point actually. So let's copy paste this. So I have here now a simple input. We say we accept JSON files. And whenever you select a JSON file, we're going to call our handle upload function. Inside our handle upload function, oh, no, it's fine. We take the file, we will parse the file. If we get a result for our file, we will pass this JSON. So the idea would be we have a simple JSON file. I think I created an example here. We have a simple JSON file which has an amount in Ether, and it has a list of our addresses. Oops, this is updated example file. Sorry. No. Yeah, let me update the addresses, because when I was testing it, some of these addresses actually don't accept Ether, which makes this whole thing fail, and this would not be this nice for the demo. Yeah. So now we actually want to show, okay, what amount did we parse out of the file, and what are the receivers. So for this, we're gonna create 2 more fields. We're also gonna use the utils to parse the number here into an amount. Actually, here we say that this number is an ETH amount, so this probably should not be that much ETH, but rather something like this. So we want to send out 0.11 ETH. Then we create 2 more fields for our receivers and for the amounts that we're gonna set. And then we can display these. So we say, okay, we don't need the fanciest UI, right? So we're just gonna say if we have an amount, if we have receivers, we're gonna, oh, let's leave this one out for now. Sorry. We're gonna show how much we want to send to each of these addresses. We list all of the addresses that have been in the JSON file, and then we say how much it would be in total that we want to send then to all of these addresses aggregated. Let's see how this works out with my React skills. So now we can press Datei auswählen, which is German for we should select a file. Sorry, this is a default input from the language. We can go to the desktop where I have an example file, and then we see it parsed out that we want to see it send 0.001 ETH to each of these 6 addresses from our proxy, and to send these funds, obviously we require 0.06 ETH on this proxy. Like if we would have a token, we could also solve this. Like if we would not use ETH but use DAI, for example, we could also set an allowance and then use the allowance. So it would not even be necessary to fund the proxy, but for the simplicity of this example, I used ETH. So this is all nice, but you know, I still need this send button, because right now it's nice that we can display all this, but we actually want to send these transactions, right? So this is where my just deleted code comes back in. So we say we have a send button, and when we press this button, sorry, I need to import the correct components from our components library. So Gnosis also provides a Safe React Components library. This library is a simple library that if you write Safeapps, that they are in line with the design guidelines from this whole safe interface. This makes it look nicer for the user, that it's easier to recognize all the elements where to press, because everything is in line with the default interface. So now we have our button. We're gonna use Now we have our button, but now we have to define what happens actually when we press the send transaction function. So let's start writing the send transaction function, and this should be a quite simple one. So we're going to create a React hook for this. And in this React hook, what we actually do is we will require that we already have the Proxy Kit initialized, that we have an announce set, and that we also have the receivers available, or at least one receiver. Else we will not do anything. So then what we can do is the Proxy Kit has a method called exec transactions. So this exec transactions, if we look at it, it takes an array of transactions. And all these transactions then will be batched together into one combined transaction that we will then channel through our proxy or safe, and they will all be executed on one Ethereum transaction. So what we want to do actually here is, right, we take our receivers, each of our receivers, we want to create a transaction where we send to our receiver the amount specified. So this already would do it. This actually is a promise. It returns us if we wait for it, it will return us the transaction hash of this execution. And actually, we need to make sure to try catch this one, because obviously the user can reject this transaction, and this would result in a failure, which we should properly handle. So to display the user a notification, hey, you just rejected this transaction, please try it again. So now if we go to our example, we can connect again. We can select the file. Maybe we should quickly check before that we have enough funds. 0.01 ETH. This is nice. This should be enough. And now if I press send, I hopefully get a MetaMask notification, which asks me if I want to execute one transaction. Now, if I execute this one transaction, we have to wait shortly. And depending on the speed of Rinkeby, we should be able to, in a second, look at this transaction on Etherscan to see that it actually have to wait again to see that it becomes fine, but what we can see here that it's actually creating the proxy and is executing transactions. So actually this account which we are using, this proxy, did not exist before. So if you can see also this account, this is our proxy, it doesn't have on Etherscan, it doesn't have any code, right? Like, so this account was funded. This was something I did in preparation for this talk. But now we created one transaction. In this transaction, we see that there was 6 times Ether transferred out to, and these should be the specified addresses. And now if we refresh this page, we will also see that now the contract is deployed here. And this is actually a safe that if we would want to, we could take this, let's put this here, and could say, we want to look at this in our safe interface. We see now the balance, and we could even see the transactions where we see that the safe was created. And sadly, this and we have a contract interaction, this one where we have all the 6 transactions. The order is a little bit tricky for our indexing service to figure out, because all of this happened in one transaction. So therefore, as you can see, everything happened at the same time. So yeah, so this is how you can use the contract proxy kit to write simple standalone apps that perform multiple transactions. But what we want to do is that it is possible that we can actually use this apps that we just wrote. Let me switch to another safe, to this one. And what, I'm sorry, I have to switch my MetaMask account. And what we want to be able to is we take our example app and we want to be able to add it as a custom app here, use it. But if we actually try this right now, we will still get the connect button, which is not exactly what we want. What we really want is that this says, hey, nice, welcome to your safe, right? Like this. And for this, we need to do some small changes. So actually, what we have to do is the CPK actually under the hood already knows that it is already a safe app now. But it currently in this version, we are trying to improve this, it doesn't have a way to actually tell us. So what we will do is we do not wait for the CPK to like we initialize the CPK already when we start our React app. We don't wait until we are connected to the Web3 provider via Web3 Connect, but we use an effect where we say where we basically initialize our Proxy Kit. Then we wait a short time, which is the time where we see the loading spinner of the safe web interface. And once we are done, we set up the Proxy Kit, we check if we are a safe app, and then we initialize the CPK. In this case, we currently have to do a little bit more manual work, but actually this manual work will allow me to explain a little bit more in detail what is happening under the hood when we initialize the CPK. As you have seen, I created this handle provider method, which is before it takes the provider and the signer to build our ESAS adapter, which we already have here. So we can actually reuse this here. No need for code duplication. And again, we store our provider, not really required here. Sorry, I need to adjust some imports quickly. So we need the signer now explicitly to have proper TypeScript. And these configure CPK and the timeout and RPC URL, these are helper methods in our utils. So our RPC URL is just an environment variable. So we set an RPC endpoint. So I have it in our .env. This is just an Enfura endpoint. And the timeout is just a simple set timeout to shortly wait to give the CPK time. And then we have this configure CPK. So as before, we build a Ethereum adapter here, but now we have to do, because we don't initialize when we create it, to prevent it from or to giving us a chance to check if it is a safe app. We need to set some things manually, which actually in other use cases also allow us to customize the CPK. So we can set for which networks or the configuration for the different networks. Currently, the CPK is available. Oh, sorry, I just saw your question. Yes, the batch transactions are atomic. So if one transaction fails, all of them will fail. This is the current implementation. Theoretically, it's on contract level possible. So with the CPK, it's possible that you adjust this behavior to have it as a way, like because we basically use another contract on chain where we can define the behavior, and we could adjust this behavior to say that even if one fails, it would not revert of all of them. Currently, this is not possible. If this is a commonly asked feature, this is definitely something that is possible to add. Yeah, as said, so currently we support the different networks, most of the test nets work. We support XDAI and Mainnet, Rinkeby, Coven, Gurley, I think even Robston. But even if you want to support your own custom chain, it's easy that you just deploy the contracts from the contract proxy kit, so the safe, some like the multisend, which is the library that I just mentioned, and the factory to your chain, and then you can configure these in your default network. Again, we have to set the ETH lib adapter. So here we use ETHs again. We could use also Web3 or if we write our customer adapters, any of our own Web3 libraries. And then if we are not a safe app, so we can actually ask the CPK, are you running as a safe app right now? So if you're not a safe app, you also need to set a transaction manager, because when we are a safe app, the web interface is our transaction manager, since all of our transactions are executed via the safe web interface. If we are running as a standalone app, so in this case, we have a default transaction manager, which right now uses your externally owned account to execute or submit the transaction to Shane. But actually, this is also a place to make use of another nice feature that Lukas mentioned before, and that is transaction relaying. So here we have another transaction manager, which is a safe relay transaction manager, which actually, if you have already a existing safe, you could also use this one. Like currently, it's not possible to create a safe over this relay manager, but if you have a safe or a proxy, you could make use of that, and the transaction then will be relayed through our service. So it would not even be required that you have ETH anymore inside the wallet that is the owner, like the connecting wallet. Also, this allows us to make it possible that other relayers also integrate with the CPK. So the example from before was the Tongue wallet is developed by Rockside. Rockside has also a relaying service which is used for the Tongue wallet, and it would be possible that they also there include like that we write a transaction manager which makes use of their relaying service. And so it's possible that each Dapp adjusts these relaying mechanisms to their needs of their Dapp. The last step then, we initialize the CPK so that all of these are built together and magic happens. Cool. So let's add the imports for these, because else we don't know. We don't need this here because we moved this, and we don't need this. Compile, obviously not. Use certain things. So yeah, what we want to do is now configure this. Yeah, we don't actually need this. Now it will complain here about the loading. So for a little bit better usability, so that user doesn't start clicking around in our interface while we actually still are waiting to render or to initialize our CPK, I'm just gonna have this loading variable that shows us a loading screen. Sorry. One more error, and then we are good to go. Two more errors. I'm sorry. That's why I mentioned live coding is hard. Cool. So now if we look at our example, this should still work as expected. Let's do a hard refresh. We just saw the short loading thing. Set networks is undefined. Yeah. That was my mistake. Yes, sorry. Obviously, it is important to also initialize the CPK. That was a mistake on my side. That's the wrong one. Web3 Connect. Yeah, sorry. Because only when we have the proxy kit, it's already initialized, so we can do this. I can try. So now we see we have our proxy again. This time it's the first one. Let's also check again what is the balance. Here we have still enough ETH to try this out again. Loading the file. And we see that this still works as our normal safe app. In this case, actually, this contract already exists. Oops, that's the wrong one. This contract already exists, so we can actually see the flow and how the transaction looks if the contract already exists. So it doesn't have to be created. While this is executing, we already will try to look, okay, how does it look when we load it in our web interface? We see there was no connect button. It automatically, the safe address is the same as our safe address here. Again, also here, we can now import our file. And when we press send, it will actually pop up our screen from the web interface. We see what safe app has triggered this. And then we see the 6 transactions that have been triggered. And when we submit it, since this is a single owner safe, it will actually also execute the transaction via our MetaMask account to perform this. Another example would be if we take a safe where we have multiple owners. I think it's this one. So if we look at our CPK TruffleCon example, and send the funds from here, we get the same dialog. We can look at the details. It's 1 ETH, no data. In this case, we will actually see that this notification now, it's actually not executing a transaction. We are signing an EIP 712 signature. So we see here, oh, it's from the web interface. We are signing for with this account, and and here's the data that we are executing. So this is now a multi-sig transaction, so it's actually quite hard to decode. This is something that needs to be improved in the standard. But actually, there is no transaction happening on chain. And if we now go to our transactions, we will see that this top transaction, if it could load the data, sorry, I need to refresh. Yes, here it goes. We will see that we have the transaction in here, which still needs to be confirmed from a second owner before we can execute it for all of these transactions. So now if we look here, we should have a new transaction in, which was from 2 minutes ago. Again, this one called this time exact transaction instead of the create. We have our 5 transfers. And also for our single owner safe, we will see that in our transaction, we have a transaction from the CPK TruffleCon presentation example where we executed all 6 of these transactions. And yes, so you can start out as a standalone app. If then you see, our users suddenly start using a lot of funds because our Dapp is so popular and they want to manage a large amount, it's easy for them to transition to the web interface where they see more details, where they have more control and can use multi-signature and increased security mechanisms to interact with the safe. So all this code can also be found in a little bit more complete version under the CPK sample employee payment. I might rename this repository, but yeah, in general, if you search for the CPK example, you will find the source code for this and how to use this to start your own projects. That would be all from my side. And if there are no further questions, that I would give it back to Lukas if he has anything else to add.
Just to mention that if you want to dig deeper into the SDKs and stuff, we have a developer portal. I just shared the link in the chat. That's when you want to start building on top of the Gnosis Safe, make sure to check out this dev portal. We should link to all the relevant information from there.